This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK and TRL Software.
I'm going to take you on a bit of a journey through this project we've been working on, and it's going to be very brief because there's lots to go at. The detail is in the paper, so I urge you to look at that. So, just to give you some background and a bit of context. So, back in 2018, there was a competition called Roads for the Future, and it was led by the National Infrastructure Commission, and that looked at ways that we can, I suppose, turbocharge our infrastructure to be ready for connected and autonomous vehicles. And so Leeds City Council put an entry in, and we were joint winners, which was great. And that was sort of the catalyst for a lot of this. And the Leeds entry basically looked at whether you could use above ground detection to get data that is CAV-like for our systems before the connected data and autonomous data is really there. I know it was touched on earlier that vehicles are connected, but here we're talking about, say, like sub-second precise positional data from vehicles, which we don't yet have. So in parallel to that competition, at the time, Leeds were undertaking a £172 million public transport investment scheme, which was looking at pushing traffic basically out of the city centre, general traffic, to improve bus journey times and reliability. Also looked at routes as well, but predominantly city centre. So major changes there. And just to kind of give context on that, a lot of the infrastructure in the city centre was very old. The signals infrastructure, and so it was ready for refurbishment anyway, but a lot of it ran fixed time control because it was very car dominated at the time, and so it ran fixed time without a lot of detection, and so there wasn't much ducting infrastructure either. So we had basically a clean slate to go at. So we had an important decision to make, and I just sort of put this up because this is a context of how things are changing in Leeds. They used to say that it was a motorway city of the north, and that was like a badge of honour. Now the new transport strategy, obviously it's not new anymore, but the transport strategy we have, it's to get to a place where we have a city where you don't need to own a car. And you can see there's lots of cycle infrastructure going in all over the place. So really push towards benefiting public transport and active travel. So off the back of that, the decision we made was that we wanted to do something a bit different. We could have gone with something like Mover or Scoop, but we decided, well, actually, on the basis of the success of the trials in the competition we'd done, we wanted to try to do something a little bit different. So I'll talk about some of the development that we've gone through in this project. There's lots of elements to this, so I'm only touching on some of the core bits of it, really. So traffic signal controller integration. So we were really fortunate at the time that there were other districts looking at doing similar things in terms of local integration of these sensors. And I should say now that the sensors we used in the trial for the competition, one of those was VivaCity, and that's where this stemmed from. So we're talking about the VivaCity sensors, if you hadn't guessed. So controller integration, yeah. So one of the other districts that was looking at this, for example, Sheffield City Council, and actually it's been really helpful that others have been doing bits of work in parallel to this, not coordinated necessarily, but it's all kind of fed into the success of this. So this is an example. So when we talk about integrating sensors into the controller, this is, you don't need an interface card, you're straight into the controller, and you have this richer data that these sensors can give you. So you've got multimodal data, classified data, going in live and volumetric as well, so zonal occupancy. So you have much richer data that you can use within the controller. But the controller integration means that you can start using the sensors to do the job of conventional detection for vehicles, for curbsides, on crossings. So this is a great example, and the two images are kind of flipped around, but it's the same junction. So you have a cycle track that goes through a junction. You've got heavy pedestrian flow across the cycle track, but the cycle track demands an additional stage at the junction, which means that the peds that are at the top, across the road at the top, have to wait basically for the cycle movement. So you don't want to spuriously demand that cycle track if you can help it. And in the interim, before we got the sensors commissioned, we strung up some conventional sensors just so that we had some adaptive control on there. And it did spuriously demand all the time. And so one of the big benefits of this, even under sort of normal circumstances, without any more sophisticated optimization, is that you have that ability to accurately discern between different types of object. So that was a really, really useful part of it. So I'm doing really quickly on this, so it just gives you an idea of the system architecture. So that controller integration is the dashed line at the bottom, so it's the local detection into the controller from the sensors. We also take out another feed into our UTMC systems, which is the detailed data, which gives us object position and type at the junction. So just to touch on some of the development we've done. So this is you can see user interface on the background of this slide. So one thing that's really important with this type of data is you need to be able to visualize it so that you can see if there's anything odd with the data. Is it sitting where it should do? And that is a plot of vehicle tracks, pedestrian tracks across the junction. So you can see they don't always follow a nice path. It depends on lots of different factors. The green arrows are our own links, and you can push those over the track so you can follow the track. And what we then do is we can snap the data to logical links. So that's a really rudimentary graphic in the top right corner, and ultimately that will display it on this interface behind it. But it just shows you that we are taking the data from the sensors, which is object data tracked through the junction, and we're snapping that onto a logical link structure that we can then use in an optimizer. So I just want to really quickly cover some of the challenges that we've had, because I think it's worth just touching on those. So commissioning brand new technology, it takes a bit of time for signal contractors to get used to it. Been some really good sort of work there, and the more we do it, the more it's sped up. I'll just move on to this. So perspective transform. So when I'm talking about wanting data where we have an object and it's in its GPS position that goes with it, you need to have some points to be able to do this perspective transform from there to kind of a plan view where you get the objects moving around. That's very difficult when you're changing the whole physical layout of the city centre. The junctions, you don't have any as-built until potentially months after these sites are done. Google's not up to date, so how do you get that information? So it's just one to sort of bear in mind if anyone else comes to doing this sort of thing. We have had to commission some additional surveys just to save time in some of these locations to get those the positions of those points. The optimizer itself, there's loads of bits and pieces here, so I'm not going to go into them in detail. They're in the paper. But what I would say is we've had lots of help from Ben Hallworth and Underdog Software, so Tony Smith. So things like mechanism to control sites. As a proof of concept, we have the Spruce control strategy in Leeds, and that's already hooked into our UTC system. So that's great. We can just latch straight into that. So those things have been really helpful to get us to the point where we can actually start looking at the optimizer itself, because a lot of this is building the platform for the algorithm itself, as anyone else who's tried doing this will probably find out. Just wanted to really briefly touch on the cost and the funding model for support, because I think this is a useful one. In terms of the cost up front of the sensors, for us for this project, it wasn't that different to having, because we didn't have a lot of ducting, no loops really in the city centre. The capital cost of this was very similar. However, these sensors, there is a cost for ongoing support of them, and I think for me, it's something that as an industry we probably just need to have a think about, because the more sophisticated this above ground detection becomes, the more it's actually in my view, useful to have a support contract with a manufacturer, or some sort of support deal with a manufacturer. Exactly how that looks, I think that's something we probably need to think about, but the idea that we can rely on signal contracts, I don't think it's fair to rely on signal maintenance contracts, is to understand the nuts and bolts of all this stuff, and you end up that you're not getting the most out of it, and you end up that manufacturers and signal contractors argue between them about what the problems are, and actually having something more formal in place I think is really useful. We just need to have a think about how we go about that. And I just wanted to touch on privacy very quickly, because we went through all the due process. We put privacy notices on the website, the council website. The centre throw away video data at the roadside, don't take any personal data at all. We still get queries about what the sensors are there for, and are they there for facial recognition and all sorts. So it's just, if you are looking at this at any above ground detection, I think this applies to, but just make sure that you follow all of the processes. And I'll hand over to Dan.
Thanks. Okay, good afternoon, everyone. I just want to talk about a few of the key advantages of the VivaCity sensor that make it particularly suitable for this kind of application that we obviously worked with Joel for a few years now on. First, it's a very versatile sensor, so very wide area coverage. We've heard this about above ground detectors. Ours is no different in that regard. And what this means is you can effectively set up multiple detection zones from a single device, and it gives you the means to essentially replace several legacy devices with just one piece of hardware. So simplifying the hardware at the roadside for detection. Multimodal data. So one of the key selling points really is the accuracy of the classification. We advertise 97% classification accuracy, independently verified. And again, this is the key advantage of this is that it's one device to replace multiple legacy systems. So you no longer need a different device for cycle detection, a different device for vehicle detection, a different device for curbside pedestrian detection. It's all in one box. And we've also recently added some extra classes, so e-scooters. We have the ability to add new classes for people that are interested in optimizing for different road users. We're now able to integrate this with all modern controllers. We've worked with the likes of Swarco, Telem, Unix, and as Joel said, this is now, there's no interface card needed. It's direct over a local network into the controller. The advantage of this is that it kind of puts the power back into the hands of the engineer configuring the controller. So with all of that multimodal data, you no longer have to configure the device itself to say, give me this type of class in this zone as a detection bit. You can configure those conditions yourself on the controller itself. So we think that's quite powerful. And finally, obviously, we're also able to provide the CAV-like hyper-local accurate detection data for the likes of the optimizer that Joel and his team are building in Leeds. On accuracy, it's a very powerful device. It's got a GPU in it, and it runs a neural network. As I said, it's high classification accuracy. I want to highlight a couple of other features that I think are quite useful to draw out. We have something we call 3D pose estimation. And what this means is that we're not simply drawing a two-dimensional box around the objects as if it was a flat picture. We have a separate model running which can estimate the kind of bounds of a cuboid around those objects in 3D space. So that significantly increases the accuracy of placing those objects in space, working out if they're in a zone that you've set up, and how close they are to other objects spatially. So that's a very powerful way of increasing the accuracy of the system. And finally, directionality. So we don't just detect objects, we track them through space. And if you track the object, you can work out what direction it's going in. And along with the high classification accuracy, this essentially the advantage in terms of signal control is that this reduces significantly the rates of false positive detections or wasted green time, if you like. So you're not going to trigger a cycle stage on cyclists cycling away from the stage who are just on the wrong side of their cycle lane. And just as a final point, it's not just for control integration. We also provide a lot of data that strategic transport modelers and planners are often interested in, available via an API and a dashboard. You can do trend analysis, and we even have some new advanced safety analysis features such as near misses, which lean quite heavily on the advantage of that 3D pose system that I mentioned before. So once you can work out how close things are together and you can project things through time, you can work out, you know, that cyclist was narrowly avoided being hit by that bus or that kind of thing. So yeah, several other features in addition to just control integration. Thanks.
Right, so we just do, I'll be very quick because I don't have the time for questions. So just to wrap up then, and it's worth just saying that the reason why we went down the route of developing our own optimizer is that at the time there wasn't a commercially available product for us to use this data, so it was important for us to be able to have something on street that allows us to have our objectives for the transport strategy, to support the transport strategy. So in summary, yeah, I think all of these things on the screen, you know, they're all a challenge in their own right, and would have been a challenge in their own right if we'd done those individually. So it's really good that we've managed to, you know, so far it's been really successful, and it's operating, the centre's operating just how we want. I think, so the next steps for us is there's a couple of sites in the city centre left to do the basic commissioning. Then we want to continue our development of our optimizer, and ideally I'll be able to come back next year and put another presentation together, a bit more information on our operational proof of concept, which I hope to have by that point. So thank you.
Right, we have time for some questions, and as we're waiting for people to stick their hand up, I have a question regarding latency. Sometimes, particularly when it comes to signal control and handing off between different software platforms and providers, there can be latency. Was that something you experienced here? Yeah,
so it definitely is, and it's a centralized system. So there's latency between street and the systems, central systems, and then there's latency between those systems depending on what they're doing. So the latency between street and the central systems is very low. As part of the city centre works, we introduced a new fibre telecoms network, which is really nice to have. And it was, so we took that opportunity. So that's really low latency. The latency between the systems is higher, and that's something that obviously once we progress beyond the proof of concept, we'll be looking at, you know, interfaces between the different kit. So yeah.
Right. Any questions at all? Where's the mic? Yeah, just up there. Sorry.
Hi, Stuart Copeland, TfL. This is something I've been looking at a little bit, detectors in particular that can detect different modes lately. Just on that detector, I can't think of an example off the top of my head, but it's possible that we'd have a location where we could use that to detect a vehicle, a cyclist, and possibly act as a call cancel. Does it, if you were to mount it in one position, could it do all those three jobs if they were either side of a pole, and how many outputs does the detector have?
Yeah, so I guess I can take that. So as I said, it's typically a very wide field of view, the camera that we have. We can also fit different types of lenses to suit particular use cases. And we also have a multi-camera option that can cover, you know, even wider field of view. In terms of the number of outputs, it's only bounded by how many detection zones you want to draw within that field of view. It all goes to the controller, and on the controller itself, you then set up your conditions for, okay, for this zone I want the call cancel, for this zone I want a trigger if only more than 10 pedestrians are waiting, or that kind of thing. So yeah, very versatile, and yeah, can do those things.
Any further questions? No, well, thank you both. Very interesting talk.